for today's lesson, we are talking about percent composition, which is the percent by mass of each element in a compound. So any compound that we have can be broken down into its percent composition, which the most important thing to remember is that all of the parts, all of the percentages need to add up to 100%. So that's a way to check yourself when you're doing these problems. Percent composition can also be called percent by mass or mass percent. They all mean the same thing, where it's the grams of the element divided by the grams of the compound, the total, and then multiplied by 100 to find that percentage. So we're going to use this equation for example 14 and 15 to figure out the percentages. So if you have 2 elements in the compound, you need to have 2 answers. If you have 4 elements, you need 4 answers here. So for example 14, when a 13.60 gram sample of the compound containing only magnesium and oxygen is decomposed, 5.4 grams of oxygen is obtained. What's the percent composition of this compound? Well, the first thing we need to know is how many are we solving for? Well, we have magnesium and we have oxygen, so those are our 2 elements. Okay? Then we're given some numbers. So we have 13.60 and 5.40 grams. The 13.6 is the total mass of the whole compound. So that's going to go in the denominator. And then the 5.40 grams is of oxygen. So if we plug this in the numerator, then that means that when we solve the equation, we are solving for the percentage of oxygen. So that's percent O for oxygen. So when you divide and multiply by 100, we're going to just round these to 1 decimal place for percentages today. So when you do that, you should get about 39.7%. So that's one of our answers. But as I mentioned before we started, however many elements you have is however many answers you need. So we have our oxygen percentage, but we still need our magnesium percent. Well, the nice thing about this is, since they all add up to 100, and when we have 2 of them, we can subtract from 100 to find out magnesium. So, for the percent of magnesium, we would just take 100 minus the percent of the oxygen, 39.7, and that turns into 60.3%. You could, if you wanted to, plug back into the equation and put the 13.60 on the bottom and solve for magnesium that way, but I find it's a little bit easier to do it this way. So, there we go. Let's do another example similar to this. A compound is formed when 9.03 grams of magnesium combines completely with 3.48 grams of nitrogen. What's the percent composition? Well, this time we have magnesium grams and we have nitrogen grams. So we have 2 elements, just like before. Alright, are either of those masses the total mass? No, they're not. So we need to find the total mass. So the total is just adding those 2 together. So the 9.03 and the 3.48. So total mass, I got to be 12.51 grams. So that's going to go in the denominator. Now, since we have grams of each element, we can choose whichever one we want to do first. It doesn't really matter. So, because magnesium came first, I'm going to do magnesium. So for the percent magnesium, we are going to put our total on the bottom, the 12.51 that we just solved for, and on top we put the mass of magnesium, which is 9.03. And then times by 100. So the percent of magnesium is 72.2%. So that's one of our answers. And then we need to also find nitrogen. So you could plug into the equation if you wanted to, or since they add to 100, we can just subtract from 100. The 72.2 that we solved for. So then the percent of nitrogen is going to be 27.8%. So that is pretty easy, right? Great. Okay. Now, if we are given just a chemical formula but no numbers, then we can still do it with the molar mass. So we just take the molar mass of the element, over the molar mass of the whole compound. The only important thing to note is you have to take the total molar mass of the element. So if there's 2 oxygens, you have to take oxygen times 2 for that top part. Okay? So example 16 is like that. So we're going to calculate the percent composition of calcium hydroxide. Well, we need to know calcium hydroxide's formula so that we can find the molar mass. So calcium hydroxide is OH minus 1, and calcium is from the periodic table with a +2 charge. So that's going to equal hydroxide in parentheses for that compound. Okay, so then to find the molar mass now, because we need total molar mass, we take calcium, there's only one of those, plus, and since remember we have to distribute the 2, we have to take 2 times oxygen plus 2 times hydrogen, and you get the total to be 74.094 grams per mole. Okay, so that's going to be our total. Now, we have this time calcium, oxygen, and hydrogen. So we actually have 3 percentages to solve for this time. We're going to break up the polyatomic ion just like we did for finding the molar mass. Okay? So I'm going to start with calcium first since it came first. And I'm going to take the mass of the calcium, so the 40.08, the molar mass of calcium, on top. I don't have to multiply by anything because there's just one of them, divided by our total molar mass that we just solved for, the 74.094, times 100, and I got that to be 54.1% calcium. So that's one answer. I can't just stop and subtract from 100 down because I have 2 more elements to go with. So we have to keep going. So let's do oxygen next. We have to take the mass of the oxygen over the total. So the total is going to be the same, the 74.094. But on top this time, since we took 2 times the molar mass for the total molar mass, we have to do that as well for the percentage. So we have to take 2 times the 15.999. And so then when you solve for that, oxygen's 43.2 about percent. And then now we can find the hydrogen percent if we subtract from 100 after we add our 2 together, which that's kind of close, sorry. So we have to take 54.1 plus our 43.2 and then subtract from 100. So hydrogen is 2.7%. So notice here how we were not given any numbers to start, so we just ran into one decimal place. We had 3 elements in the compound, so we had to solve for all 3 numbers. So that's it. Examples 14 and 15 are like the gum portion of the activity, and then 16 is like the back side of that paper. Let it